wrong file. Hey folks, good to see you again, or hear you, or you to hear me. I suppose that's it. But again, as you're going through this, if you listen to it and you need to get some questions answered, shoot me an email, and I will be more than happy to help you out via email as best as I can. Remember, this test is really important for you guys to do well, especially as we're working on to some more difficult stuff in the next few chapters. So make sure you apply yourself and get focused and get the job done. First, if you have any additional things that you can study from, that'd be a good thing. One example of that would be the review packet that you got for that quiz on Thursday. That's pretty exhaustive for 11.1 to 11.3. Anyways, number 1, find the next 4 terms of the arithmetic sequence. Arithmetic sequence, there's a common difference. It looks like it's going down by 7 each time. Oh no, it's going down by 8 each time. So this one's going to be -9, then minus 8 again. It's going to be -17, minus 8 again is negative. Minus 8 again, -25, minus 8 again, -33. Alright, let's take a look at the next one. Next 4 terms, geometric sequence. That means there's a multiplier, there's a common ratio. It looks like we are going to be multiplying by 5 each time. So 10 times 5, 50, 50 times 5, 250 times 5, 1250 times 5, 6250. Sweet. Alright, next one. Find the 19th term. A sub 19 means the 19th term of this sequence. Let's see what kind of sequence it actually is for. If you notice that it looks like it's going up each time by kind of a steady rate, and actually that's add 16 each time. So the common difference is 16. That means it's an arithmetic sequence. If it's an arithmetic sequence, we know that this is the case. By the way, how am I doing this problem? How do I know what I'm doing? Well, first I'm identifying what kind of sequence it is. Then I'm throwing out some equations and kind of using those equations as I can. So common difference is 16. We're looking for the 19th term, so n is 19. A sub 1, which is the first term, is 16. So a sub 19 then, and we're just going to calculate that and we'll get our value. Turns out to have a value of 304. So a sub 19th, or the 19th term, is going to be 304. Write an equation for the nth term of an arithmetic sequence. This is an arithmetic sequence, so we can figure out the difference, which would be the difference between these two terms are going to be 93. It's going to be the common difference. So, okay, that's what our D is. Then arithmetic sequence, we know this to be true. So then we start sticking stuff in and see where we get. D is 93. N, we want to keep N because we're talking about an equation. By the way, an equation is going to be the closed form of the arithmetic sequence. And then we need our first term, -416. So we go ahead and simplify that when we're asked for an equation, and we get a sub n equals 93n minus 509. Woohoo, we did it. Next problem. Alright, number 5 is kind of a different representation of what we need. Notice this is the first term though. If there's 3 blanks between, this would be the second term, that would be the third term, that would be the fourth term, and this, guys, that's the 5th term. Look at that. So we know what a sub 1 is. We know that a sub 5 is 41. We don't know what D is, and that would make it easy if we knew what D is. So let's go ahead and find D. There's another way to do this. I just feel like doing it this way. I'm going to do this, right? And there's a D in there, and I'm going to solve it for D. A sub 5 is 41 when n is 5. We don't know what D is, but we sure do know what a sub 1 is, so we're going to do that. Then we're going to simplify. Oop, I switched those terms. My bad. And we're going to solve it. 41 minus 17 going to be 24 equals 4D. 24 divided by 4 is going to be 6. So we're left with a common difference of 6. That means we just add 6 each time. So we have 23 plus 6 is going to be 29, plus 6 is going to be 35, and then we'll do another plus 6 just to double check, and bam, 41. Nice job, team. Let's go ahead and number 6. Find the following sums. So it's a series, first off, and let's see what kind of form it is. It looks like it's going up by a steady rate of up by 3 each time, and that looks consistent, so we're going to call it an arithmetic sequence with a common difference of D. So let's just start throwing in some stuff. We want the sum, so we're going to use the sum formula for arithmetic sequence, which happens to be this guy. Okay, and then we're going to start putting stuff in. n, we don't know what term that is. I suppose you could keep counting d as we go up, but I'm going to do it a little bit different way just for fun because it's a little bit more regimented and a little bit higher, difficult process to use, and you might have to use that on the test. So I'm going to do it the harder way. A sub n is 32 in this case, which is the last term, and divide by 2. So, but we still don't know what n is. So let's go back to another formula that relates a sub 1, n, and d, and we can figure out kind of what n is. We know what a sub n is 32. Sorry, I wrote the wrong number. It's 32. A sub 1 is 5 plus n. We don't know it, but we know what d is. Let's simplify this and solve. Plus 3n minus 3. 2 plus 3n. We'll keep solving. 30 equals 3n. N equals 10. That's nice. So we change that to 10 and the sum of the first 10 terms, and we can calculate it. So we go ahead and we get s sub 10 is equal to 185, and that's going to be the sum of that series, or it's going to be the sum of that sum. This is another sum. It's a series. It's in sigma notation. We know it's arithmetic because it's a linear equation there with a d of 3 because that's the slope as well. So what we can do is we need the sum of the first 18 terms because it starts at 1 and goes to 18. It's the sum of the first 18 terms. So we're going to do 18. A sub 1 we don't know. A sub 18 we don't know because we want the sum of the first 18 terms, so we go up to 18. But we can find those using the formula 10 times 3 times 1, that'll be 13, so a sub 1 is 13. A sub 18 then is going to be 64. Oop, I don't know why my pen's not working right now. That's frustrating. Hold on. Here we go. We got it to work again. And then we calculate what the... Alright, so s sub 18 then. It's going to be 693. Woohoo, we did it. Good job. Alright, let's work for the next one. Find the first 3 terms of the arithmetic sequence based on that. Oh, this is interesting. Notice how we're given, when we're talking about the 10th term, okay, the 10th term, when n is 10, the 10th term is going to be 41 in this case, and then the sum of n, sum of a set of terms is going to be 230, or the sum of the first 10 terms is going to be 230. So we're going to use that formula for the sum of the first n terms of an arithmetic sequence, and then we're going to start substituting some in. S sub n is going to be 230, n is going to be 10, a sub n is going to be 41. Okay, and the reason why I did that is because I knew I was given this information. I didn't even actually look down here. I just assumed this is going to help us find some stuff. But if you look down here, your first comment was, oh, we need to find a sub 1, a sub 2, and a sub 3. So your first comment might have gotten you here. And then you realize you don't know what d is, you don't know what a sub 1 is, but you know what n is, but you're still going to be kind of stuck. So we first have to find a sub 1, and we need to find out what d is. So let's just kind of move back to another piece to see if we can get there. So here we go. So let's try to solve this. 230 divided by 10 would be 23. And then I'm going to multiply by 2. It's going to be 46. And then a sub 1 plus 41 minus 41. A sub 1 is then going to be 5. Okay, so that's good. Now, but we still need to find out what d is, which is unfortunate. But we have this other equation that relates all this stuff. So we're going to start substituting the things in that we know. We know what a sub 1 is. We want to find, say, a sub 2, but that's not going to help because we don't have a d. But we do know that a sub 10 is 41, so we're going to put that in. And that's going to get us somewhere we want to get. So we get 41 equals 5 plus 9d. We're going to minus 5, 36. Then we're going to divide it by 9. It's going to be 40, or 4 rather. That's silly. So d is going to be 4. So we go up 4, 9, up 4, 13. Fantastic. Alright guys, a disclaimer on this. When you notice how this review guide is is based by sections, what you'll want to do is make special note that you can identify whether it is arithmetic or whether it is geometric before you do any of the work, because we might not necessarily say this is a geometric sequence. you know, you might just say find the sum of this series, and you need to figure out that it's a geometric sequence. Or even with the summations too, you'll have to kind of identify which one's what. But first, find the equation for the nth term of geometric sequence. Okay, that means what is the multiplier? So I'm going to do 175 divided by 25. It's going to give me 7, so I know that the multiplier is going to be 7. And we can check that, keep going if you want. But I know that with a geometric series, this is, or sequence, this is our closed form, or our equation relating to the nth term. So I'm going to start putting stuff in. A sub n equals 25 times r, which is 7 to the n minus 1 power. There you go. We're done. Barbecue pork. Alright, number 9, a sub 1. Find the a sub 1 given this kind of setup here. This is interesting. So we're given a sum, so let's remind ourselves what the sum of the first n terms are of a geometric series or sequence. That's an n. It's r to the n, guys. Okay, so let's put some stuff in. We're given some other information. Thankfully, we're given the rate. We're given what s sub n is, so it's 1295 equals, we're not given a sub 1, that's okay. And we're given 1 minus n, or r being 6, and then n being 4. So we're going to put that in, and then 1 minus 6. Alright, so then we're going to evaluate and rewrite this equation here. We're going to evaluate that thing in the parentheses. So then 1 minus 6 to the 4th, then that all divided by negative 5 is going to give us times 259. Then we're going to divide both sides by 259. That's going to give us 5. So a sub 1 is going to be 5. Woohoo, we did it. Alright, next one. Evaluate the sum. Notice it's in summation notation, sigma notation. We start at 1, we go to 8. If we start at 1, and this is a geometric series, which it is, we can use the sum of the first n terms of a geometric sequence. So we can just start cranking this out, put things in we know. That number out there, given the model, that's going to be a sub 1. That number in there is going to be our rate. But you know what we can do? We can replace this n. We can make that n 8. And then we can evaluate this. S sub 8. It's going to give us the 8 terms. So make sure you evaluate that correctly, guys, because on the quiz I know we had some trouble with typing these things into our calculator. And that was unfortunately the reason why we didn't get some of them right. So make sure you actually do it yourself and get negative 9840. It's your sum of the first 8 terms. So this equals negative 9840. Good job. Woohoo. Let's go on to the next section. Alright, find the sum if it exists. Okay, let's figure out what series this is. Looks like it's going to be a negative because the signs are changing. And it's got to be multiplying, so it's going to be multiplying by negative 2. Check it. Good. So that's the rate. So our rate is negative 2. By the way, that absolute value of that rate is greater than 1. So the sum of the series does not exist. Okay? For this one, it's going to exist because that absolute value of r is less than 1. So we're in good shape. But it's also to infinity. So it's an infinite geometric series. So we actually need to do s equals a sub 1 over 1 minus r, and that's the sum of an infinite geometric series starting at 1 going on to infinity, and we can actually do this. Woohoo. So s equals a sub 1 is going to be 50. 1 minus the rate, 4/5, and we get what that equals. We just divide that out. And make sure you do this correctly, guys, because if you're not, you're going to have issues. Make sure you type it in yourself and get 250. Alright, here we go. We didn't have time to do those because I wasn't here. But let's take a look at this pendulum problem on the next video. We're going to start at 13. We're going to keep going. I'm going to thoroughly explain this again, and we'll have enough time. Thanks, and we'll see you. Email me if you have any questions as you're working through this, of course. We'll see you on the next video. The only bad thing is I can't queue multiple videos because I don't have a pro account of this thing.